This video is about maximum and minimum values of a quadratic function. We'll start with a definition, which is this. The y-coordinate of the vertex of a parabola is, first of all, a maximum value if the graph opens downward. So you'll recall from parabolic graphs or quadratic graphs, a parabola could open downward. And recall from graphing these that the vertex in this case would be at the top of the graph, which is why we would call the y-coordinate of it a maximum value. It's the highest point on the graph. Similarly, a minimum value of a graph is the y-coordinate that opens upward. So again, recall a graph of a parabola opening upward would have a vertex at the bottom of it. Therefore, the y-coordinate of that would be the smallest or minimum value of that function. As we've already seen in graphing parabolas or quadratic functions, there is something called standard form, and as we're defining it, this is the f of x equals a times x minus h squared plus k. In that form, of course, we know the vertex is the point h comma k, and we've been finding a vertex to graph a parabola in this form. And if you find the vertex, then you're right on track for knowing what the minimum or maximum value of the whole function is. It's just the y-coordinate of that vertex. And as we already discussed, that vertex is either at the bottom of a parabola or at the top of it, and it corresponds with whether it's a minimum or maximum value. And those correspond to, of course, that leading coefficient of a being positive or negative, as we've seen already in graphing these. But now additionally, let's also discuss how we can use general form to decide on a minimum or maximum value. Again, recall, general form, the way we're defining it, those authors differ on this. General form we're saying is f of x equals ax squared plus bx plus c. And so, yes, we can complete the square to turn that form into our standard form, as we've been doing to graph. But you also, in some cases, want to just be able to go right to the min or max value. And to do that, let's discuss a way to represent the vertex in general form. It's this point where the x-coordinate is negative b over 2a, where b and a correspond to the coefficients in the general form. And then the y-coordinate of the vertex would be whatever the function value is when you plug in that x-coordinate that perhaps you've already found. Let's do an example where we want to find the minimum or maximum value of the function. Now this first example is given in what we're calling standard form. Let me read it as y equals negative 3 times the quantity x minus 4 in parentheses squared plus 7. Now, as you'll recall, we've already been working with this form, calling it standard form, and to graph with this form, we could start by finding the vertex, but as we just discussed in our notes, the vertex is directly related to the minimum or maximum value of this function. So let's recall the vertex is h comma k, and in this case, that would mean 4 comma 7, getting those values directly from the standard form locations we've been using. If the vertex is 4, 7, that's useful, but we also have to discuss whether this function or parabola is opening upward or downward. So we look in front of our function and observe that a is negative 3, that leading coefficient way out in front being negative 3. So that means if a is less than 0, which it is, we have a parabola that is opening downward. But if it's opening downward, the vertex is at the peak or the top of it, which means we're looking for a maximum value for this case. Now, the max value happens to be the y-coordinate of the vertex, but so would it be if it were the minimum value. We just look always for the y-coordinate as we said in our notes above. So our, in this case, max value is just the y-coordinate, and that is 7. The x-coordinate tells us where that would occur on a graph, but it is not the actual max value. The y-coordinate is. Let's do a second example where we want to find the min or the max of the function. This time the function reads y equals 2x squared plus 4x minus 1. Now recall, this function is given in what we've been calling general form. And in general form, as we set up in our notes, let's recall, the vertex has an x value of negative b over 2a. And then the y value will be us plugging that back into the function. So let's first figure out what negative b over 2a is. In this given function, remember, a, b, and c are the numeric constant coefficients in this equation. So b, in this case, would be the positive 4. So negative b would be negative 4 over 2 times a would be 2 times, and then a is that leading coefficient, which is 2. If we simplify this, we have negative 4 over 4, which would just be negative 1. So then the y value of the vertex will be whatever we get when we plug in negative 1 to our function. So this would be 2 times negative 1 squared plus 4 times negative 1 minus 1. This would be 2 minus 4 minus 1, which would be negative 3. Okay, so let's start to put this all together. We now know that our vertex is the point negative 1 comma negative 3. We can look at our leading coefficient, which for this example is 2. So a is 2. Of course, that means a is positive, which means this parabola would be opening upward, which means its vertex would be at the bottom of it, which means we're looking for a minimum value in this case. So we'll say the min value, of course, it's equal to the y coordinate of the vertex. We already found that as negative 3, and so there is our min value. Our third example says to use a graphing calculator to find the maximum or minimum value of the function. This function reads y equals 3x squared plus 7x minus 1. So to use a graphing calculator, of course, we'll go ahead and turn on our calculator and then go to the equation editor, which is the y equals button in the top left corner. Make sure to clear out whatever else might be in the way, and let's start with y1 equal to our function, which is given as 3x squared plus 7x minus 1. Once we type our function in, we want to go look at it in the graph. Now, we don't know exactly how our window is going to be for this yet, so let's just do a standard, maybe a zoom 6 to get a nice standard window that's zoomed out a little bit, and make sure we can see what we're expecting in the picture. Notice in our function, the a value, the leading coefficient, is 3. Of course, that means a is positive, which means the graph is opening upward, which is exactly what we're seeing in our calculator. Of course, that means we're expecting a minimum value where the vertex is at the bottom of the graph. We can find that value of the vertex by calculator as long as we can actually see it in the picture. So sometimes you might have to adjust the window to make sure you can actually view the bottom. In this case, we can by hitting zoom 6. So we'll work with that. If you want to zoom in closer, that's okay, as long as you can actually see the bottom and be a little bit around it, left and right, that's all you need. So to find the bottom, or the minimum in this case, that vertex in the calculator, we'll do as follows. We'll hit the second key and then the trace button, which above it says calc. We want to select the item in the list here that we're already anticipating using, which is, as we discussed from the a value, we're expecting a minimum value here. So the third option says minimum. We'll go down and select that, which will take us back to the graph. Now, when it takes us back to the graph, there should be a flashing cursor on the graph, and that cursor will move if we hit the left and right arrows on our calculator. So you can kind of watch the cursor move. You'll notice, though, if you hit the up and down arrows, the cursor does not move. So we're only using the left and right arrows for this. We're adjusting only the x coordinate of our cursor here. Now, we already selected the minimum function on this calculator, so notice there's a question in the bottom left corner that says left bound question mark. That means, as we've used in other contexts, we want to go to the left of where we think the minimum is, but not too far to the left of it. So just stay a couple clicks away from where the bottom might be. And once you are clearly to the left, just hit enter. Then the question changes to say right bound. So again, scroll to the right until you pass the minimum. You can tell by the y coordinates of your cursor now starting to increase. So just go a couple clicks past and then hit enter to the right side. And then it wants a guess. So go maybe back down to where you think the bottom might have been or close to it. Hit enter, let the calculator think for a moment. And then it will give you the coordinate. Now it says minimum in the screen. That's the function we're using. And then it gives you an x value and a y value. Well, those happen to be then the coordinates of the vertex. We know that this minimum point represents the vertex in the parabola. The calculator is not calling it that, but that's really what the point coordinates are that it's giving you. And we know, furthermore, that the y value of this vertex would be our minimum value of the function. So we'll round this to a tenth and just call it negative 5.1.